This is Srikala, Mathematics Department from Easy BTech. Today I am going to explain about mean values theorem in Mathematics 1. Mathematics 1. So before going to the topic, please like, share and subscribe our Easy BTech channel. So Mathematics 1, I am going to explain about mean value theorem. Mean value theorems. So mean values theorems is one of the important topic in engineering mathematics. So before giving the total explanation about the mean values theorems, so doing the discussion about only the two definitions, they are continuity and derivability of a function. So what is the continuity? A function f is said to be continuous. A function f is said to be continuous at the point x is equal to a. So if satisfying the condition, limit x tends to a, f of x is equal to f of a. This is the limit condition for continuity. Limit x tends to a, f of x is equal to f of a. And the second definition, derivability of a function. So a function f is said to be derivable at the point x is equal to c. So if we satisfying the condition, that condition is limit x tends to c, f of x minus f of c by x minus c exits. So if this condition exits here the value, then you can say that the function f is derivable at the point x is equal to c. So this is the continuity definition, students. Limit x tends to a, f of x is equal to f of a is the continuity, and derivability, limit x tends to c, f of x minus f of c by x minus c exits. So now coming to the Rolle's theorem. Rolle's theorem. Rolle's theorem statement. The statement of Rolle's theorem. So what is the statement of Rolle's theorem? The statement is, if f maps a comma b tends to R is any function such that satisfying the condition f is continuous on closed intervals of a comma b, and second condition, f is derivable on open intervals of a comma b, and third one, f of a is equal to f of b. The main three conditions of Rolle's theorem: f is continuous on closed intervals of a comma b, f is derivable on open intervals of a comma b, f of a is equal to f of b, then there exists at least one element, only, students. That element is c belongs to a comma b such that f dash of c is equal to 0. This is the main condition of Rolle's theorem. So f is any function such that it is continuous, derivable on a comma b such that satisfying the third condition also. So if any function satisfying all these three conditions, then there exists at least one element such that existence of that element belongs to the open intervals of a comma b, where satisfying the condition f dash of c is equal to 0. This is the statement of Rolle's theorem. Coming to the problem related to the Rolle's theorem. The first problem, that is verify Rolle's theorem verify Rolle's theorem for f of x is equal to x into x plus 3 e power minus x by 2 in the given intervals of minus 3 comma 0. This is the problem here. So now doing the solution of this problem, the solution verifying. So to verify Rolle's theorem, three conditions are there: continuous on the open intervals, derivable on the closed intervals, f of a is equal to f of b condition. So at first writing the given question, that is f of x is equal to x into x plus 3 into e power minus x by 2. The first condition, verifying the first condition, that is continuous condition. So since here it was given that f of x is a polynomial function, it was given that f of x is a polynomial function, so hence it is continuous. Polynomial is continuous here. Polynomial function, hence it is continuous. Hence it is continuous on the open intervals only, minus 3 comma 0. And coming to the second condition. So what is the second condition? Derivability. That means doing the differentiation of the given question with respect to x here. So at first, before doing the differentiation, doing the multiplication with x here like this. So x into x, x square, and plus 3 into x, 3x into e power minus x by 2. Yeah, doing the differentiation with respect to x. So here product of two terms are there. Then you have to apply u into v procedure here. Differentiation of u into v. Then x square plus 3x. And doing differentiation of e power x. E power x differentiation is e power x only. And again doing the differentiation for the function, that is minus 1 by 2. And plus e power minus x by 2. X square differentiation is 2x and 3x differentiation is 3. Using u into v procedure. Doing the simplification, and this minus, students, minus e power minus x by 2 by 2. Remaining terms x square plus 3x, and here e power minus x by 2 and 2x plus 3. So observe here, and in these two terms e power minus x by 2 is common here, making common of e power minus x by 2. E power minus x by 2 is common. Then x square plus 3x by minus 2 and plus 2x plus 3. So now finding the LCM of this function, bracket term LCM only. You are finding LCM, e power minus x by 2, and LCM is minus 2, students. X square plus 3x minus 4x and minus 6. So simplification, e power minus x by 2 by minus 2 x square minus x minus 6 is the final differentiation answer. E power minus x by 2 by minus 2 x square minus x minus 6. So according to this solution, we can say that here f of x is derivable on open intervals of minus 3 comma 0. This is the second condition. First condition is continuity, second condition is derivability, and the third condition is verifying f of a is equal to f of b. So here according to the given question, a is equal to minus 3 and b is equal to 0. It was given in the question, students. Then our question, f of x is equal to x into x plus 3 e power minus x by 2. Now in the place of x, we have to find out the value of f of a. Substitute the value of a as a minus 3 here. Then minus 3 plus 3 becomes as a 0. Now coming to the b, f of b, and here the value of b is 0. Substituting the value of x as a 0 here, then this value is also equal to 0. So what you notice here, students, the value of f of a is equal to 0, and the value of f of b is also equal to 0. So what we know is here, then here f of a is equal to f of b. So now observe here, the three conditions are satisfied for this problem: continuous condition, derivability condition, and f of a is equal to f of b condition. So here f of x satisfies all the three conditions of which theorem? That theorem is Rolle's theorem. So according to the statement, if any function satisfies all three conditions, then there exists at least one element. C belongs to a comma b such that the main condition is f dash of c is equal to 0. F dash of c is equal to 0. Now equating f dash of c value to 0. Then according to the second condition, we know the value of f dash of x. That is e power minus x by 2 by minus 2 x square minus x minus 6. So we need the value of f dash of c here. In the place of x, you please substitute the value of c here. E power minus c by 2 by minus 2 c square minus c minus 6 is equal to 0. Simply substituting in the place of x as c to get the value of f dash of c here. So now equating to 0, then here the exponential function need not be equating to 0 here. That means it is not equal to 0. Then equating the second product term as a 0. C square minus 6 is equal to 0. Then c square using the factors 3c plus 2c minus 6 0. C common, c minus 3 plus 2 common, c minus 3 0, and again c minus 3 common, then c plus 2 is equal to 0. Equating the product term individually, c minus 3 is equal to 0 and c plus 2 is equal to 0. Then c is equal to 3 and c is equal to minus 2. So what is the statement of Rolle's theorem? There exists at least one element c belongs to a comma b is the main statement. So now we got the values of c as a 3 and minus 2. But here the condition, according to the condition, c belongs to the open intervals of a comma b. But our statement states that here at least one element is enough here. At least one element belongs to the open intervals here. Then here our intervals was given as minus 3 comma 0 and values are here 3 comma minus 2 here. Then verifying these values 3 and minus 2, which value is belongs to the given intervals here. That means c minus 2 is the value which is belongs to the open intervals of minus 3 comma 0. So then satisfying the three conditions, existence of one element where that element belongs to the given open intervals. So hence you can say that for this corresponding problem, hence the Rolle's theorem is verified. Rolle's theorem is verified. That's the one problem related to this question. Coming to the one more problem related to the same topic. That is Rolle's theorem. Yeah, second problem, second question. Verify Rolle's theorem for f of x is equal to sin x by e power x in the interval 0 comma pi. Yeah, the solution. That means proving. Now the first condition, continuity f of x, it was given that it is sin x by e power x on the intervals 0 comma pi. Verifying the first condition, So here f of x is the trigonometric and exponential terms combination, and f of x is continuous. F of x is continuous on the closed intervals of 0 comma pi, and second condition, f of x is equal to sin x by e power x. So I have to do the differentiation with respect to x. Now before doing the differentiation, f of x is equal to sin x into e power minus x, applying u into v procedure only. Then f dash of x is equal to sin x e power minus x differentiation minus e power minus x plus e power minus x, sin x differentiation is cos x, then minus e power minus x sin x plus e power minus x cos x, making e power minus x common, e power minus x cos x plus sin x. It is the value of f dash of x. So at first writing the positive terms cos x, and then writing the next term, yeah, here minus here, so writing minus cos x minus sin x, e power minus x is common, cos x minus sin x. So hence f of x is derivable, f of x is derivable on the open intervals of the values, that is 0 comma pi. And the third condition, so f of a is equal to f of b, and here a is equal to 0 and b is equal to pi, then f of a, so that means substituting in the place of a as a 0 here, sin 0 by e power 0, it is equal to 0, and f of b, that means sin pi by e power pi is equal to 0, because we know that sin pi value is 0 only. So 0 by anything is 0. So it was clear that here students, here it was clear that f of a is equal to f of b. So these are the three conditions. So what are the three conditions, students? First one is the continuity, second one is the derivability, third one is the f of a is equal to f of b. So then there exists at least one element, that element is C, which is belongs to the open intervals of a comma b, such that the condition, main condition of Rolle's theorem, f dash of c is equal to 0. Then the value of f dash of c. Then according to the second condition, we know that the value of f dash of x is equal to e power minus x cos x minus sin x. Then simply substitute in the place of x as a c here, f dash of c, e power minus c cos c minus sin c, and equating to 0. Then we know that the exponential terms need not be equal to 0. The equating the second product term as 0, cos c minus sin c 0, cos c is equal to minus c sin c. So both cos and sin trigonometric functions are equal in the value of c is equal to pi by 4. Now c value is pi by 4, students. Our interval is 0 to pi was given here. Then the value, c value is belongs to the 0 comma pi. So according to the Rolle's theorem, so hence Rolle's theorem is satisfied. Rolle's theorem is satisfied. Rolle's theorem is satisfied. Yeah, one more problem about Rolle's theorem. Verify Rolle's theorem. Verify Rolle's theorem for f of x is equal to e power x sin x minus cos x in the interval pi by 4 comma 5 pi by 4. Yeah, the solution. So at first writing f of x is e power x sin x minus cos x. On the intervals it was given as pi by 4 comma 5 pi by 4. The first condition, obviously it is the combination of trigonometric and exponential terms. Then f of x is continuous on closed intervals of pi by 4 comma 5 pi by 4. And second one, f of x e power x into sin x minus cos x. Have to do the differentiation with respect to x, applying u into v procedure, students. E power x into sin differentiation is cos, minus cos differentiation is minus sin. Already minus is there, becomes as a plus sin x plus sin x minus cos x. Exponential differentiation is exponential only. Now doing the multiplication with this function, students, e power x cos x, again e power x sin x. Here also e power x sin x minus e power x cos x. Now doing the cancellation of these two terms, e power cos x, e power cos x, remaining terms 2 e power x sin x. So according to this one, you can say that f of x is derivable on the open intervals of pi by 4 comma 5 pi by 4. Continuous for closed interval, derivable for open interval. Coming to the third condition. So here a is pi by 4 and b is 5 pi by 4. So first verifying f of a. So f of a means f of pi by 4. So substituting in the place of x in the given question, students, in the given question, e power pi by 4 sin pi by 4 minus cos pi by 4. So what is the value of sin pi by 4? Sin pi by 4 is 1 by root 2, cos pi by 4 is 1 by root 2, then 1 by root 2 minus 1 by root 2 becomes as a 0. We are coming to the f of b. So f of b. So what is the value of f of b? F of 5 pi by 4. So 5 pi by 4 and sin 5 pi by 4 and cos 5 pi by 4. So sin 5 pi by 4 value is minus 1 by root 2. Cos 5 by 4 is also minus 1 by root 2. Then becomes as a plus here. Then the value here is equal to 0. Then you can say that here f of a is equal to f of b, students. So satisfying the three conditions. What are the three conditions of Rolle's theorem? F of x is continuous, f of x is derivable, f of a is equal to f of b. Then there exists at least one element. What is that element? That element c belongs to a comma b such that f dash of c is equal to 0. So f dash of c, in the second condition, we know the value of f dash of x. F dash of x value is equal to here 2 e power x sin x, and we need the value of f dash of c, then 2 e power c sin c equating to 0. Then exponential terms is not equal to 0. Then sin c is equal to 0. C is equal to, using inverse trigonometrics, sin inverse 0. So c is equal to 0. C is equal to pi. C is equal to pi. So where this value, c value pi, belongs to the open intervals of pi by 4 and 5 pi by 4. So continuous, derivable f of a is equal to f of b condition satisfying existence of one element where that element is also belongs to the given values, given intervals. So hence you can say that here Rolle's theorem verified. Rolle's theorem verified. Yeah, in this session we discussed about the statement of Rolle's theorem, related problems to Rolle's theorem.